I'm going to do Leetcode number 136, single number, and you're given an array of integers, and one of these integers is not repeated twice, but all the others are. So basically, we got this one, 2, 2, 1. So the only one that isn't repeated twice is 1. So we have to find that number that isn't repeated twice. Now, you're asked to do this in linear time complexity, that is O of n. And then for space constant, O1. So can you do it that way? Now the trick here is we have to learn about bitwise operations. And the big name here is XOR. So you have to understand the properties of that. So I'm going to basically just go over it, if you don't mind, what XOR is. So given bits, right? Bits is it's an integer, either 0 or 1. Usually you think of 0 as false or turned off. And 1 is like true or turned on. And given two of them, let's call one A, one B. If you do the A XOR, exclusive OR, that's what it stands for. This is called a truth table. So basically you can go from, if you give A 0 and B 0, that's going to be 0. And then if you're going to give A 0 and B 1, it's going to be 1. And then you're going to give A 1 and B 0, it's going to give you 1 as well. And if you're going to give 1 for A and 1 for B, that's going to be 0. Now, if you look at the truth table, you conclude that if the A and B are equal, that is 0, 0, or 1, or 1, that means the XOR is going to be 0. If they are not equal, the A is not equal to B, the XOR is going to be 1. So that's the truth table for XOR. Okay, so you have to understand that. Now, given that, you have to understand the properties of XOR. For example, if you have A, and the symbol that they use, at least in Java, that's the language you're going to use for the XOR, is the caret. So I know some logic, it could also mean and, but in this case, it's going to be the XOR, okay? So if I XOR B, but I happen to take B to be A, that is A and B are the same, what is the result of that? So if you XOR of itself, the number is going to be 0. That's the result, okay? Because remember, XOR, if you have them equal, you get 0. And then if you have another property, which is if you take A and XOR with 0, what does that give you? It gives you the number itself, which is A. Okay, so knowing these two properties, you can solve this problem. So let's go. So here we have the integers, and we've got to find the right one. Well, if I take, like, for example, here, if I take 2, I know 2, there's all of them are going to repeat twice except 1. So if I XOR the same thing with the same thing, that gives us 0. So if I 2 XOR 2, that's going to be canceled out. And then at the end, we're going to get, if I XOR with the 1, remember, if I XOR 0 of that, I get the number itself. So if I have 0 XORed with 1, I also get the number itself. So if I XOR all of the elements of the array, everything will be canceled out except 1. And that very 1, because it's XORed of 0, will become just itself. That's how we find it. Okay? So let's go here. So basically, we're going to keep track of the XOR running sum. So I'm going to make a variable here. Let's call it num. And I'll initialize to 0. Remember, it's fine to initialize to 0 because if I XOR with the existing, which is 0, I just get itself. And at the end, I just return that number that I'll set while I traverse in a loop. So we need to know how to traverse an array. So basically, a for loop I'm going to use. Initialize int I equals 0, I less than nums.length. I'm using Java with the nums as primitive array of ints, so I don't have parentheses. And increment the I so I don't have infinite loop. So basically, I'm going to take num, whatever it is, initially it's going to be 0. We're going to XOR with the current value, current element that I'm iterating upon. So if I XOR, which is the caret in Java at least, and I suppose other languages might be similar. So if your language doesn't work with this, let us know. We can look it up. Anyway, we're going to do nums at position I. And then we're going to store that back to nums. And as I'm doing the XOR, right, 0 XOR 2 for this example, it's going to be then XOR 2, and then XOR 1. You know they're going to cancel it out. In the end, we're just going to get the number itself, okay? So 0 XOR 2 is 2, and then 2 XOR 2 canceled out back to 0, 0 XOR 1, 1, and that's why we got the 1 back in the end. I think you can also do caret equals if people who like shorthand notations. That's also a possibility. I don't know. Let's try if that shorthand can do. There you go. Accepted answer. You can add 2, 2, 1. You got 1. Nice. Case 2, 4, 1, 2, 1, 2. So that one basically x 0 XOR 4, 4 XOR 1. You got something. And then XOR, it's going to cancel out eventually. These ones and the twos. If you do the math and write it out and rearrange, okay? And you got the 4 because the 1 is going to be there. There's no duplicate, so it's going to be remaining. And that's it. You just got to know the bitwise thing. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right, thank you so much, and I'll see you in the next one.